Hey Stat Cats, Larry C here. Yesterday my tires were a little low, so I went to the gas station to go fill them up. And could you believe it? They're charging $1.50 to put air in your tires. Man, that's pretty high. I guess it might be due to inflation. Shout out to you all. Hope you enjoy the video.
Come on now, dog. Come on, man.
All right, what's going on, everybody? Hello, Stat Cats. It's Mr. C here, doing another video for Build a Stats course with me. And in this one, we're going to do section 2.2 on histograms. So after giving it some thought, I figured maybe I'd start this section out with another one of those memes that I make on image flip. Let's see if I can zoom in here to show you guys it. All right, due to inflation, a picture is now worth 1,024 words. Fa! Oh, hang on, where's it at? My apologies to the earbud gang. Okay. Now, what made me think of that meme? Well, what made me think of it was that, hang on, what's going on here? Escape this here. Shrink me down a little bit. Okay, so what made me think of this is that basically in this section, we're going to be looking at nothing but pictures or graphs, which are, in this case, pictures of data. So that's the connection that I'm trying to make with that meme. And as it says here in this section, we look at visual representations of a frequency distribution. So this kind of dovetails off of the previous section 2.1, which was exactly on frequency distributions. And those were essentially tables with classes, midpoints, lower class limits, so on and so forth. So if you want to take a peek at what that's all about, just check out the video prior to this one. And what I did is I used the definition from I always have to look at it, the Elementary Statistics by Mario Triola, 14th edition. I'm not sponsored by them in any way, but I do want to give justice where due and do due diligence. By the way, fair use. So a histogram is a graph consisting of bars of equal width drawn next to each other. The textbook actually uses the word adjacent for that. I think this is a little more clear for our students, unless there are gaps in the data. And then I kind of split up the definition for that into a two-pronged case here. The horizontal scale represents the classes of the quantitative data, but it sometimes consists of categorical data too. So if we're working with nominal data. And then the vertical scales represent the frequencies or relative frequencies. This is all stuff that we're going to write down together when I present this section of notes to the class. So I then phase into a variety of histograms, but a quick note prior to doing that. So it says here, it is common to use class midpoints, class boundaries, class limits, or categories for the horizontal scale. And maybe I should emphasize that with an underline, or what I would probably prefer to do is bold italics. Okay, so that just emphasizes that we're looking horizontally when considering these different pieces of information. So what took up the bulk of the time, quite honestly, making this section of notes is finding a good variety of histograms. So that's kind of one of the missions of, at least in my opinion, one of the missions of professors is to, well, not only give their own personal perspective on this information. I mean, after all, when students sign up for your particular course, a lot of times they're signing up for you. And so I recently discovered that Pearson, the publisher for this book, has a lot of different learning resources, including notes that are kind of in the style where it's guided notes. And I was a little bit bummed out because, it would be really easy to just use theirs as opposed to building mine from scratch. But I'll tell you what, as a teacher, when you build something from scratch, you know that really well. Okay, so um, it makes it easier. You have more buy-in, and there's a lot more passion using tools that you've created versus using somebody else's. Now, that's not to say that you shouldn't use anybody else's resources. I mean, that's what they're there for. I mean, if you're in a bind and you need a worksheet, in a pinch, let's say like you find out an hour before class, then there's no problem printing off some resources that have come from the author. I mean, that's what they're there for. But my main point, just to kind of circle back to this part of the video, is just part of our jobs as professors is to give our unique perspectives to students, make it interesting, and I like to do my best to give a variety of things. Um, because if you just keep it very minimal and say, okay, this is what a histogram looks like, and maybe you give one or two, um, you're kind of doing a disservice to the students, but also you're going to get more questions from them in the form of what if, or does this one, and so on and so forth. So you can really knock out a lot of, stones with one bird, as Chuck Norris would do. All right. So with that said, the following are histograms. Pay close attention to both the horizontal and vertical scaling and see what information you can infer for them. And then I decided a little bit later on to add this part in where it says identify each as either a frequency distribution or a relative frequency distribution. Okay, so these two graphs right here come from our textbook. This is a histogram for books read in a month. And you can see the horizontal scaling uses numbers. And then we have books read. And so, maybe a person read 2 books in a month. Maybe a person read 3 books, 4 books, 5 books, or 6 books. And then the vertical axis is the frequency. And so this kind of gives you an idea of the sample size. So there would be 1 person that read 2 books in a month, 3 persons that read 3 books in a month, 5 persons that read 4 books in a month, 2 people that read 5, and 1 person that read 6. Okay, and so we are essentially providing a count of the number of people in here, and further classifying the number of books that they've read in a month. Now I'm going to come back to this perhaps later on in the notes because this is an approximately normal distribution. This histogram came from the textbook as well, and this deals with data, I believe, for Los Angeles traffic times or commute times. And so we have the commute times on the horizontal axis and then the frequencies on the vertical axis. And so you can get the sample size by just counting how high each one of the bars are and adding all those heights together. And then what I want to point out is that the numbers on both the horizontal axes for these two histograms, they actually happen to be class midpoints. And the reason why we would know that is because they're labeled like dead center of each vertical bar. So we have 7, we have 22, 37, and we could actually infer the class width based on this. You can just subtract, 2 consecutive classes, a class midpoint. So we have 22 minus 7, giving us 15, 37 minus 22, giving us 15, and so on and so forth. And we could even infer the class lower limits and upper limits. This would not necessarily, in my opinion, represent a normal distribution. It appears to be skewed right, which that's something that I'll get into later on in this video. Then I pulled something up from the New York Times. This is ages of first-time mothers in 2016. And here we have a frequency distribution, a lot of different ages labeled along the horizontal axis. And if you look closely, these are class midpoints as well, but they're not all class midpoints. If you take a closer look, you can see that there are some histogram bars that don't have a label underneath them. But if you look at the vertical axes, you can see that these are percentages. So I'm really hoping that the students identify this correctly as a relative frequency distribution. And this kind of appears to be a normal distribution, but there are two peaks. So that's something that we would classify as bimodal. And I kind of like this one. This looks like it's saying, come here. But this is from a software that we use at our college called My Open Math. And this was taken from one of the problem sets that I've used for my online stats course. And so again, we're just looking at, in this case, it looks like lower class limits, upper class limits are being used as opposed to class midpoints. Okay. And then I wanted to throw in some categorical data looking frequency distributions. The first one I built collecting data from my wife, Mrs. C's monthly reading book count. And so she's been reading books all year long, and she's been keeping track of some stats on these books. And so yesterday I asked her if she had a list of like how many books that she read in January, February, March, April, and May. And she definitely did. And she sent me this information. And Mrs. C so far in 2026 has read six books in January, 5 books in February, 6 books in March, 11 books in April, and 6 books in May. And what I really like about this is that it kind of appears to be somewhat of a uniform distribution, but there's one peak right here. And 11 kind of seems to be somewhat of an outlier. And it's going to bring up a great discussion point with them. Like, can anybody give me a reason why Mrs. C read 11 books in April, whereas it looks like she's reading, roughly 6 books per month otherwise? And I really like to see why they think that might be. And spoiler alert, it's because she had spring break that month because she's a teacher as well. And then I put this in there. Notice that it's not a graph per se, but there is some information that you can get out there. This is information or data from my personal YouTube channel, and this is information that could be constructed into a histogram, and you could kind of tie this into a Pareto distribution, or a Pareto histogram. But I want to let the students know that sometimes histograms are present even if there's no graph there. So sometimes you have to go the extra mile and construct the actual axes for the histogram. So if this were me, these categories would go along the horizontal axis, and then these would represent my vertical bars. And it would represent a relative frequency distribution. Okay, so that's a 2-word variety of histograms. This is something our author mentions in this section. It says aspects or characteristic of histograms to look out for. Now, it says here CV dot. That's an acronym for center, variance, distribution, aka shape, outliers, and time. So I think at this point we will definitely be able to understand what this means. Center, I think you could probably introduce the idea behind that in this section, although it's not until chapter 3 that we get down to actual like mean, median, mode, and those versions of a center. You might be able to introduce the concept of variance. So for instance, with Mrs. C's monthly reading book count, we could kind of think of an average number of books, but also there's a little bit of wiggle to these heights. And that's kind of what variance is how the data points are spreading out. when compared to the mean. Outliers, I think students probably have prior knowledge of what an outlier is coming into class, so that shouldn't be too bad. And then time, this will actually be, I would say, further understood in the section following this one, where we kind of look at time series things. All right, so I made a 4-chart thingy, Bob, here again, this time for common histogram shapes. And what I did is I had a Claude give me some examples of a normal distribution, a uniform distribution, something that's left skewed, something that's right skewed. And these are the graphs that it provided me. And in each one of the boxes with the graph, I'm deciding to put just kind of something to hook for their minds to hook onto in terms of, like easy descriptors of what these look like. So for normal distribution, the most common thing to compare this to is the shape of a bell. So that's why I have bell shaped here. And this particular histogram is for data that Claude generated on heights of adult humans. And so you can see that we have the different heights listed along the horizontal axis, and then we have the frequencies listed along the vertical axis. And then the next one is a uniform. And as I was making this section of notes, I thought, a uniform distribution, when you plot it, it kind of looks like piano keys. So I'll see how that resonates with the students and report back to you guys. But a uniform distribution, most of the bars have a relatively equal height. And so rolling a fair-sided die would definitely give way to a uniform distribution. So if you think about a fair-sided die, has the number 1, or has a side with 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, and 6 dots. No CV dots. Yeah, what should I do with that? Let me do this. All right, anyway. And so if you were to roll a dice, any number of, well, not any number, but, many of times, and graph, how many times the single dot showed up, how many times the 6 dotted side showed up, you'd end up with a uniform looking distribution. And that's because the probability of landing on any of the 6 sides is all the same. All right, so a 1/6 chance of landing on a 1 dot side, 1/6 chance of landing on a 2 dot side, and so on and so forth. And then skewed left, you can think of as like a left foot. If you were to, take your foot out of your shoe, your left foot, and take your sock off, most feet kind of have this shape going on for it. All right, so the big toe on the right and then the small toe on the left. And this is a left skewed distribution, which can kind of be a backwards concept because the taller bars are on the right. I always like to say to students that imagine that these vertical bars are rubbery, and imagine taking like a balloon over here and just expanding it, then it would start to make this stuff push over to the right. And so whatever side the balloon's on, that's the type of skew it is, okay? So if I'm pushing things to the right here, then that would mean the balloon is on the left-hand side. And you can contrast that with skewed right, or a right skewed graph, by having the balloon on the right-hand side. Okay, so if I were to expand a balloon over here in this upper right-hand corner, that would begin to push these towards the left. But age at retirement is a good example of data that's left skewed. All right, we don't have a lot of people retiring at 30, but definitely a lot of people retiring in their, early to mid 60s. Shout out to 6'7" right there. And then compare that to annual household income. All right, that's definitely data that's right skewed, because there aren't really a lot of people that are making 200K or more per year. Okay, that's not to say there are exceptions. There are lots of exceptions to these things, but this is just information that Claude dug up for me, and I would say it's fairly accurate. Okay, there aren't very many people making millions of dollars per year, but there are kind of a lot of people making around 30,000 a year, 45,000 a year, so on and so forth. All right, so the second half of the notes, this third page is where we're going to actually do some examples. Okay, so everything leading up to now is just kind of like some intuition building and sort of touchy-feely stuff, getting the flavor of these types of histograms. But I do want to make sure that the students can construct these sorts of things on their own. So I put this example in there, and I kind of jazzed it up. It says here, the following frequency distribution summarizes the number of tornadoes in Oklahoma in each year for the past several years. Use the frequency distribution to answer the following parts. And the actual problem wanted, let me see what it wanted here. All this problem asked for was what the class width is. And that's really easy to do. You can just subtract 20 minus 0 or 39 minus 19. And the idea there is just to take consecutive lower class limits and subtract them. Or you could subtract consecutive class midpoints to get the class width. A common error, though, is to take the upper class limit and subtract the lower class limit. 19 minus 0 is 19, but the official class width is actually 20. So I'm going to instruct students to look vertically to find the class widths. I figured, since the previous section introduced a lot of vocabulary surrounding frequency distributions, that I would kind of test them on that within the notes. So I'm going to have us list out the lower class limits. All right, that would be 0, 20, 40, 60, 80, so on and so forth. List the upper class limits, so 19, 39, 59, 79. The class boundaries, so the first class boundary between 19 and 20 would be 19.5. You could also do negative 0.5 as a class boundary. And, the second to last class boundary would be 139.5. And according to the author, the official last class boundary would be 159.5. List the class midpoints, so you add the lower and upper class boundaries and divide by 2. Okay, so if I add that, if I add 0 plus 19, that's 19. Divide that by 2, that would be 9.5. And then 20 plus 39 is 59. And so, the average of that would be 29.5. I don't know why I had a brain fart with that. But you could then, infer the rest of the class midpoints. And then we already addressed the class width. Another thing that I wanted to do with this was show them how to sketch this out by hand. And what I did for this grid right here, and I'll explain why I wanted this one, but what I did for that is I just did a quick Google search. And I typed in graph paper. And I looked at images. And I don't want something that's too dark. I actually wanted something that would resemble graph paper that they could buy on their own. And so I selected this one right here. And I right-click, open image in new tab. And so I got this, and then I took a screenshot of it. Something like that. And then I just pasted it in here. Now, why I chose to use this versus something else is because I really want to give it like a grassroots type of feel. like, bare bones, like how would you sketch one of these frequency distributions out just from pure scratch, all right, using the frequency distribution. So I think that it's going to be really instructional to help students think through their horizontal scaling, like how many tick marks would be beneficial for each class width, and also the vertical scaling. All right, we have a lot of technology that auto fits graphs for us, like the graphing calculator, TI graphing calculator, or Desmos. But it's always good to kind of go back to the raw basics and, create something that's very low tech. Because not everybody has access to that technology, but we should still be able to do the math regardless. So that's why I elected to use this this type of coordinate grid. So yeah, we'll just take the classes and decide on whether we want to use the lower and upper class limits or the class midpoints, and then we'll figure out our vertical scaling based on these numbers, and then we'll sketch things out. And then the section closes out with some technology tips. So I'm not going to go through this page in great detail, but I might run them through this part since a lot of my students will likely have a graphing calculator with them in class. But if not, if it's at home, then they can click on this QR code my wife made for me, where Mario Triola, the author of the textbook, has some calculator tutorials on there. So maybe we'll confirm the histogram that we got using the TI-84 in class. If there's time, I could pull up Microsoft Excel, or even, what is it? Not Google Sheets. Yeah, Google Sheets. I don't know why I'm having brain farts today. But yeah, or I could pull up Google Sheets and show them how to generate a histogram in there. But if you're wondering how to do that while you're watching this video, I can show you what I did here to get the data for Mrs. C monthly reading book count. So I'm going to open up Microsoft Excel, and I will have January in this first cell, February, March, April, May. And in January it was 6, then 5, then 6, then 11, then 6. So what you could do is you can enter your data into 2 columns and then just click and drag to select all your data, including the specific months. And then you can go to Insert and open this up. By default, it wants to put it into a histogram anyway. So if that's the case for you, you can just go ahead and put OK. And then you can double click up here to change the chart title. So Mrs. C's monthly book count, something like that. And then it doesn't come with the labels for the horizontal axis or the vertical axis. So what you could do there is you could hit plus and then select the axis title option, and you can go in and edit the axis titles to your liking and even shift them around. To get the actual data values on top of the histogram bars, you go back to this plus sign and then you can select data labels. And so what I did is I just right-clicked, copied and pasted that into Word, or maybe I screenshotted this and put it in there that way. But eventually I'll come back to Excel and show you guys how to make a pie graph. And that basically closes out my plans for this section 2.2 on histograms. And that's going to end the video. So thank you guys for hanging in there. If you have any questions whatsoever, let me know. Otherwise, I'll see you in the next one. Shout out to all Stat Cats.